Welcome to 99 zu 1. I am Nadim. I'm your host for today. And today we will talk the tech industry and the left. Why is that even important? There's a lot going on there that we should be aware about and we should have a good analysis over. But we actually really don't. And there's one person that talks and writes about this a lot, and that is Dwayne Monroe. He is here right now. Welcome, Dwayne.
Thank you, Nadim.
Yeah, good to have you here. Let me maybe give a short introduction to your person. Dwayne Monroe is a cloud architect, actually, and a Marxist tech analyst and internet polemicist based in Amsterdam. He's currently writing a book. It's called Attack Mannequins, and there he's exploring the use of AI as propaganda, if I'm correct. Dwayne applies his nearly 30 years of experience in the industry as a technologist to the exploration of the tech industry's impact on society and political economy. He runs the blog Computational Impacts at monroelab.net. I will also link that in the description of the video afterwards, in which he writes about a lot of cool stuff, like, for example, how Star Trek got AI better than we get it today, right? Yeah, have I missed anything? Is there anything else you want to say, Dwayne?
I think that is a fair summation. Yeah, that sounds good to me.
Well, just before we start, maybe so you know whom you're talking to, I'm a computer scientist myself. I studied computer science and graduated with a PhD like nearly 10 years ago now, and I'm also in the industry since then. I'm now actually in like working closer to management. But yeah, I know a little bit of the things that you are going to be talking about, and since a while I actually thought to make an episode on this myself.
Yeah.
But I like in this format, I always prefer to have guests here to talk about that as the experts, so they don't like my audience doesn't have to believe me, you know, they can believe someone else. All right. I mean, maybe let's give a short, introduction for people that are new to this topic. Your blog description starts, for example, like this. Monroe Lab is dedicated to exploring the role of technology in our lives from a materialist and political economy point of view, with a special focus on the artificial intelligence industry. Can you explain what it means to have a materialist point of view on the role of the tech industry?
So I'll give you a direct example. When we talk about the tech industry, what do we usually talk about? For example, apps. The iPhone as a magical device, for example, or just mobiles as they currently are, as technology platforms. But we never, or very rarely, unless you're a particular type of geek, you don't talk about hardware. You don't talk about supply chain. You don't talk about lithium mining. You don't talk about labor. You don't talk about the fact that there are human beings involved all along this process to make computation happen, and that computation is an industrial process. It is not a magical process. It is not disconnected from the industrial world. And when I started my career, this is how the tech industry was presented. We were in the third or the fourth, I forget now. There's so many marketing hooks. Industrial Revolution, and in the United States, where I'm from, this was presented as being a post-industrial situation, that we were liberated from concerns about actual manufacturing because of computation. But what was being obscured through that line of argumentation, and I would say propaganda, was the fact that the very computation that we were building our dreams upon, so to speak, is in fact an industrial process, and therefore can be analyzed from that perspective.
Yeah, excellent. I mean, there was recently something happened that was interesting. I don't know if you're aware of this Google Photos feature that Google basically allowed for like 4 or 5 years to run now. Without any payment. It was completely for free, and it basically allowed any user that has a phone to upload their images to the Google store. Of course, there was some limitation on how big the images are supposed to be, etc. But yeah, it was like a pretty cool backup feature. And it was supposed to make you think that, well, there is actually this infinite space, and Google is now offering that shit for free. So great. And that changed actually a month ago. I don't know if you followed that, but Google actually is now taking money for that. They are not allowing more to store unlimited amount of pictures. There's like a 15 gigabyte cap. So, I mean, this kind of marketing hook is pretty common in the industry. I'll get you in for free, and then 6 months later you get some, some fees or something like that. But at the same time, it's also like, okay, that took 4 years. So maybe there's also other considerations from Google's side there, where they say, well, all the storage space is actually costing money.
Yes. Yeah, because what these companies never talk about, unless you are a specialist in, say, data center operations, or you work for Intel, or you work for one of the manufacturers of storage. I mean, EMC may know, or Seagram, or other companies may know. They do know because they supply. But the general public is led to believe that it is indeed an infinite resource that you can simply keep sending things to. And that's why whenever there's an announcement of some new usage for surveillance technologies, what I think about is the eventual collapse, which is a theme I've been picking up on recently, of these infrastructures that are being built, because it is not infinite, and it cannot infinitely scale, because it all lives in a data center, or I should say data centers, scattered across the world. And there is a requirement to, of course, build more data centers and consume more real estate, and have more computational power and storage and interconnecting equipment and so forth, and people to actually man these locations. And so there are natural limits that are not being publicly talked about when it comes to computation. And so if Google were to say, hey, you know what, people, yes, I know we're Google and we have this mountain of capital. However, we did the numbers, and my God, the rate at which this is being used is quite challenging for us to actually keep up with, from a material perspective. So now we're going to start charging. Not only is it a way to make money, but it's probably also a way of imposing a limit, because, of course, by a limit that does not expose the actual material character of what's happening.
Yeah, exactly. That's also what came to my mind. It's like, probably, I mean, normally these marketing hooks, if it's just like a bait and switch, and they are offering you something for free, and then they want to get you afterwards, that doesn't take 4 years.
Right, precisely.
They don't hook you for 4 years, and then they ask you for some money.
I mean, like I don't know, in a Hollywood movie, a drug dealer would give you like one free hit, right? Not 4 years of supply.
Yeah. Okay, let's still stay a little bit with the intro. Tech industry. How do you define that? What is tech industry for you?
So, and this is actually an excellent question, because when people use the term tech industry, they exclude industries that use technology, such as aerospace, or material science. There's a whole that's called STEM, in some worlds. But of course, by tech industry, what we are referring to are the companies that grew up in Silicon Valley in California, North American firms primarily, actually, sadly, entirely, because can anyone think of any non-North American firm that is talked about broadly as being a part of the so-called tech industry? So Silicon Valley based, or emergent from that world in one, whether or not they are actually in Silicon Valley. Amazon, for example, based out of Seattle. So and that industry that builds platforms. The company now known as Meta, Facebook, of course, Microsoft, Google. These companies, made their billions, and their, I guess, nearly trillion, depending upon where the market cap goes, based upon the construction of platforms that, in, I suppose you could say, Marxist terms, are rentier platforms. And in other words, they are extracting wealth by renting out, by being in between you and the thing that you want. And so that is, I think, a fair definition of what we mean when we say tech industry. It's a sloppy term. I'm not very fond of it because, as I said, it leaves out an entire
Yeah.
category of technological activity. But but in real world terms, that's what we mean.
So also in broader terms, we would also mean, for example, innovative automotive industry, right? So Tesla would also fall into this category. Like, I mean, somehow Tesla is also this kind of mixture of these.
Tesla's shoved into that because it's considered to be a software company that happens to build a car around their software platform. And
Right.
indeed, evidence for that is the fact that they continue to unfortunately push the idea of this full self-driving debacle, which Ford Motor Company would not waste its time on that because Ford is an actual car company, right? I mean, I'm just saying, I mean, they have decades of experience. They know how to operate at scale. Toyota, or Volkswagen. I mean, these are companies that know how to build at scale rapidly to retool. Obviously, they're not perfect, but I think you understand what my meaning.
No, no,
Whereas
absolutely. Yeah.
the idea of Tesla was, we have this brilliant software platform, and of course, electrical power train, and then we can build the vehicle, a luxury vehicle around the software platform. That was not the vision of the actual founders of Tesla, Turpinning
Wait,
and
are you talking about Elon Musk?
Elon Elon Musk, as those of us who've done our homework know, invested some capital and then performed a bit of Bonapartism in Tesla and seized control of it. Because
He actually bought the title of founder. He bought the rights to
That's
call
right.
himself the founder of Tesla.
It is amazing. It is amazing. I mean, the
Yeah.
original company was, what was it called? AC Propulsion, and I believe it was Eberhard who became wealthy because he was involved with the first ebook reader called Rocketbook, I believe it was, in the 1990s, and he had some capital
Okay.
from that, and he wanted an electric car, and he and his partner Tarpening, I believe is his name, invested some capital in AC Propulsion, and then the name was changed in 2013 to Tesla, and then they needed capital, they needed an investor. Musk had some money from what had happened from his work with Thiel and the very sinister Thiel. In what I forget the name of the company now, PayPal, and
PayPal, right.
and because of that capital, he was able to buy his way in and provide them with needed capital. But then, as you say, things went badly for the actual founders from there, as things go for anybody who associates themselves with Mr. Musk.
Yes, yes. It's another episode
That's
for
a whole
another
other
meeting.
show.
Yeah, exactly. All right. Good. Tech industry. We have that more or less down. Then, I mean, your main theme is AI.
Yes.
And then I know from experience, people listen to some podcasts. So now people say also machine learning. They say even sometimes deep learning.
Mm-hmm.
Can you pull this apart for us a little bit? What is that? Like, what's AI? What's machine learning? Maybe what's deep learning? Is there AI? Will there be?
So the term artificial intelligence was coined in, I believe it was 1956, at a conference of computer scientists at Dartmouth College. And an early pioneer in the field of computer science, John McCarthy, I believe he coined the term as an aspirational descriptor of what they were working towards. There was no illusion, at least not on the part of McCarthy, that they had actually achieved AI or that they were close to achieving AI. It was just a matter of, the question was, what are we trying to build? Now, in those days and up until the 2000s, the field of artificial intelligence research was in the hands of universities and governments. And there were various ups and downs. There were moments when people felt that, when researchers and scientists felt that they had made major breakthroughs in the creation of algorithms and architectures, actual hardware architectures, such as parallelism and connectionism, that's a difficult word to say, the work of individuals like Danny Hillis, who I'm sure you're familiar with, and who worked not too far from where I lived in Philadelphia for a while. There were hopes in the 60s, the 70s, the 80s, and the 90s that various breakthroughs in the field, at the hardware level and at the level of the mathematics of the algorithms, which would produce interesting effects, effects that in previous generations were not possible, that these breakthroughs were actually taking the field closer to the creation of machinery and systems that could mimic or perhaps match or perhaps exceed human cognition. But what has been happening all along is that what is being built is pattern matching and correlation and inference engines. And so, what we're calling machine learning, if you have a spreadsheet and you create a table and you use linear regression on that table, but you may recall from your stat lessons in high school or in college, you're doing essentially what machine learning does. So for example, when my bank card was flagged because I was in a place where I wasn't using my bank card previously, although on the background, the level of mathematics is rather complex. Essentially, what was happening is that there was a table of locations where I'd been, and this table and this new location was not along that pathway of known locations over a period of time, and so it was flagged as being an unknown and perhaps fraud. I called the bank, and the bank said, "Oh yes, Mr. Monroe, thank you. We will release your card." Um, that's a real life example of machine learning. Deep learning is simply a matter of iterating through that process multiple times. It's not terribly deep, actually, but the term it's like another marketing term because it gives you the
Right.
impression that, well, something deep must be happening. Well, it's like, no, we've simply created multiple layers in which we're doing iteratively this movement through data to find patterns. So what is being called artificial intelligence is essentially pattern matching. Now, with greater hardware and with, I would say, sophisticated mathematics that companies or organizations like OpenAI can bring to the table because they have capital to hire extremely smart people, they can create more elaborate effects, such as we see with GPT-3, which is a correlation of word order, or DALL-E, which is a correlation, another large language model, and in a way, large image synthesis model, in which it's a combination of pattern matching of, or rather, the ability to anticipate based upon probability what the next word might be in response to words that you offer. Uh, these are interesting. They're mathematically impressive. They're computationally impressive. But the real question is the book worth the candle, as the old saying went? And my argument is that it is not, because when you peel the layers of the onion, what you are seeing are data centers, and you are seeing game processing units, thousands of them, thousands upon thousands of them, storage arrays, teams of site reliability engineers, all to present this elaborate parlor trick, which to this day, no one seems to be able to actually state what the real world use of this is. Like, how is it helping you and me? It's helping OpenAI, it's helping Google and other companies, but the ability to create text that seems as if it was created by people, because it's gathering data from people, from Reddit, from Wikipedia, from Twitter, from Facebook, and so forth, finding those patterns, and then probabilistically finding what the next word should be if you offer a prompt. Who is that helping? And this is really, I think, a key question that we need to ask and answer.
Yeah, we'll get to that in a minute. I like just one fact of one of your articles where you actually talk about, well, it's actually a well-known fact that especially this language model that took Reddit as an input turned out to be incredibly racist and insulting when actually then trying to talk to it, because it took credit as an import
because it used reference.
Exactly. Yeah, that's that was a funny fact. Okay, then what is the cloud, and I mean, you are a cloud architect. What are you doing?
So the cloud is a method of providing computation, database, and storage primarily as an abstracted utility. Um, as I've said in a few other interviews, when I started my career, to provide computational ability to a corporation, um, I and my team members, my colleagues, would be racking computers like from Dell or from Compaq or from IBM or even from Sun Microsystems in earlier days. We would be racking these in elaborate large racks and then putting power to them and then wiring them up into the corporate network and then configuring them and then making them available. For example, I worked for a material science firm, and that company purchased, I think it was $8 million in True 64 Unix hardware. It's a rather impressive array that was created there. So what the cloud makes possible is the ability of that same organization today to, rather than have someone like me or a team of people, obviously, do all of that physical labor and then also configure it and do all these things, to actually just utilize the computational power that we were physically putting online for the corporation, make that computational power available to the organization, as I said, as a utility. And they are build platforms. So there are different categories of cloud services. There's SaaS, anyone who uses Google Drive and Gmail itself, actually, or Office 365, or I think it's called Microsoft 365 now. You're using what's called software as a service. Anyone who is using AWS, Amazon Web Services, Azure, Google Cloud Platform, these are build platforms. And by that I mean, rather than simply, although you are consuming it as a utility, you also have the ability to write code, to deploy things to it, and to configure your own solutions, your own services, built using software on those platforms. So there's a greater amount of versatility, but the actual underlying computational database and storage ability is indeed offered as a as a utility.
Yeah, I mean, it reminds me a little bit. I mean, AWS is, for example, I mean, that's the one that we work with. It's like one of the most common. And it provides you not only with the storage space, but it gives you all these other services. I don't know, provisioning and performance measurement and and hundreds of services.
It's a unified. And one of the things I neglected to mention is that one of the selling points of cloud platforms, what are called public cloud platforms, is a unified application programming interface. So everything emerges from the exact same platform, essentially, which is why you can then do these cross-functional types of analysis and tying services together.
Right, and it's like, for me, it reminds me of some kind of, it's like an abstraction of the computing that you had to do back then.
Exactly.
Where, or think of, people still remember probably these, what you see is what you get. Web editors,
which we used to call WYSIWYG. Yeah.
WYSIWYG, exactly.
Yeah.
So in the past, everybody had to code their own website. And then suddenly these companies pop up and say, well, we have this kind of editor and you can just drag, items, and then you have your website.
That's right.
And I mean, it's obviously on a much higher level, but that's basically what happens. And of course, for this kind of abstraction service, they charge the fee. And then you have experts, AWS experts that speak only those languages and know how to use that tool. Because, I mean, ultimately it turns out to be, because the underlying, let's say, the hardware, the infrastructure level is incredibly complex. So the software level on top of it also turns out to be very complex.
Precisely. Yes. Yeah.
And you have to be trained in this for 6 months in a company before you can do stuff.
That's right. And this is ironic, because I recall, I mean, when I first pivoted my career from on-premises to cloud, which I describe in that Logic magazine article, actually. But the impetus was the idea that it would indeed be simpler. Excuse me. So it was hilarious when it turned out to not be simpler at all, and in some ways a bit more complex, actually,
Absolutely. Yep.
than what I was doing. And because the with on premises, that is to say, with computation that is deployed within a data center, um, each computational device, each server, is its own world. But we would knit them together, of course, via the local area network, and then perhaps if you're a larger organization, a wide area network, and then onto the internet. But each unit represented its own world, and there was no unified substrate that allowed them to actually to work in concert. Although there were, like SETI at home, there were versions of that software which allowed, for example, the spreading of in batch processing, the spreading of computational load across multiple CPUs, across multiple computers. That's similar, but not as deep as I said, the unified API of cloud. So yeah, it is in fact quite complex, and that's why the demand for the kind of work that we do is quite high, and it's apparently quite difficult to find people. I since moving to Europe, this is one of the things I've noted, that the demand is extraordinarily high, actually, for skilled individuals.
Yep, yep. I mean, it takes, as I said, it takes a lot of time and takes sometimes
Yeah.
years to have someone that you can like for a person that does only AWS management, for example, to call this person a senior. Like, it's not something
Yes.
that you learn in 2 months or so. You have to
Not at
make a
all.
lot of experience.
Not at all.
And all these errors and edge cases that happen and pop up. Like, I mean, that's not so different from the tech admin roles of the past, right? I mean, ultimately,
except for one.
you don't have to run there anymore.
Well, oh my God, I remember, when I was in my 20s, it seemed as if every time I had like a really great date, my phone would ring because some stupid server was having a bad night. Always on a Friday night, always when I had a fantastic date. Anyway, but the but the other thing is that another major difference with cloud from on premises is that it was impossible to actually acquire hardware without the corporation knowing. So, for example, my team, or the team I worked for, or worked with, I should say, we couldn't simply just acquire True 64 Unix boxes and just put them in the data center. We had to go through the procurement process and then wait for delivery and then have them installed. But with cloud, it is possible for developers, for anyone,
Click,
to
click.
simply click, and then next thing you know, you spent €1 1 month and €1,000,000 the next month, because you can simply deploy very rapidly, which is one of the value adds from the perspective of companies. But it's also one of the, I think, the challenges for these hyperscale vendors, because my position, or my feeling, is that the level of complexity is getting to be too great, and we're running up against not natural limits yet, although those are inevitable, but the limits of what is permitted via complexity theory, which is something that I study rather intently. But we can get into that later.
Oh yeah, complexity theory. That's another important thing that I want to tackle at some point here. But let's maybe talk a little bit about the misconceptions. You already hinted at that. There are hypes, there's propaganda, there are misconceptions. So what in your, and maybe now talking from a left perspective, what in your view are the most common misconceptions about AI, or maybe the tech industry at large? And
so let me answer that by actually telling you why I started doing this. So I was watching one of my favorite left podcasts about a year ago. Pardon me. And
which one is it? 99 zu 1? Is it 99 zu 1?
Well, actually, as it happens, you've done a crossover with this podcast. This
is revolution.
Precisely. And so there was a discussion there about self-driving trucks, and I believe it was Pascal who he was just sort of throwing out a question, which was, will self-driving trucks have an impact on the labor prospects for truckers? And I thought that, well, that's, I mean, the answer is no, because self-driving trucks are impossible. And so my, I mean, it's just impossible.
What?
There's just way too many edge cases, as we say, for any computation to handle. And in fact, there was a guest on the show that particular day who was a trucker. I believe her name is Angela Walker. And she said no as well, just based upon a common sense knowledge as a trucker of all the things she had to do. And then saying, well, could a computer do that? And just without necessarily having the technical background, it was just a logical conclusion, even having worked with computers. And then when you say that, well, we're building AI, what companies are talking about is building AI in massive data centers, not in the form factor of a truck that can navigate, the ever-changing reality that we navigate when we're driving. And so it occurred to me that there was a lack, and not for anyone's fault. Not everyone's had the experience I've had, working with this technology at scale over, a number of decades. So it occurred to me that there was a need, I would say, a need to have someone who understood the language of the left, who actually had studied Marx and Engels, who studied complexity theory, who was studying cybernetics and game theory, who viewed capitalism as a problem, to be, and who believed in public goods governance, socialism. That for a person with that perspective and the technical knowledge to actually speak up. And so that's why I started the blog, was to provide a resource for the left, and really anyone who's interested, but primarily for the left, to say, well, we're hearing about all these things, but how should we analyze them? And my point isn't that there aren't actual threats from the tech industry. My point is to identify the true threat. So the true threat is very rarely or almost never the science fiction idea. It's something else. It's almost as if you're being misdirected to this other idea instead of looking at the actual danger. So in the case of the supposed automated trucks or self-driving trucks, the true danger was the attack on labor via the propaganda idea that self-driving trucks were approaching. Now, they would never achieve the self-driving truck, but what they could achieve is a shaking of the confidence of labor in their own value, and therefore have the ability to lessen benefits, to lessen pay, to do various things, saying, well, we could replace you with this self-driving vehicle, which doesn't exist. However, the idea that you can present this idea, that it does exist or it soon will exist, is a powerful propaganda tool. And so that's why I started doing this.
Yeah, and it's propaganda that is incredibly effective to some extent, right? I mean,
it's very effective. It's very effective.
Vast swaths of the population that do believe. I had a discussion about this a month ago with a friend that seriously and honestly do believe that automated driving is just around the corner. It's just a matter of, maybe matter of regulation, and that's it.
That's right. And this is because of often a well, I mean, there is of course a lack of technical background, but also we have to understand what ideas are hegemonic. And in our culture, in Western culture, global culture, really, science fiction ideas are indeed hegemonic. So whenever anyone sees, and I've used this example many times because it's a quite powerful and useful example. Whenever anyone sees a Boston Dynamics Spot device, which is really a drone, but they call it like a robot, people always reference the same Black Mirror episode, right? Metalhead. And they assume that because they see this thing moving, that it is a self-directed device that will then come after us and kill us. But the possibility of it being used to attack us is very real. But what's being missed is that it has to be remotely operated. So there's a relationship that's being missed because the science fiction ideation prevents us from actually identifying the real problem. And so it's difficult to break out of that science fiction frame because it's part of the air we breathe, which is ironic because say in the early decades of the 20th century, science fiction was considered trash. And then I think I recently watched a documentary in which the documentarian made the brilliant point that it was the atomic age, the detonation of atomic bombs that actually brought science fiction into its own, and rocketry, because people said, "Oh my God, what is this?" And so that's when science fiction in the 1950s really sort of flourished, and we've been living in that moment, I think, ever since. The frame has changed from, say, atomics and rocketry to computation, but the idea that anything is possible, that we dream up, is still abroad in the land.
Yeah, not to defend science fiction. I mean, obviously, I think
I'm a
like
fan of science fiction. Yeah, I am
just as
indeed a fan.
There are a couple of movies that actually, I mean, mostly satiric movies, but they display this in a very, exactly this problem in a very good way. I think of RoboCop right now, right?
I love RoboCop. Yes.
Like these machines that are super intelligent, and suddenly they shoot one on the board. Bah, 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 bah. Okay, now
right,
we need a human in the machine to operate the freaking machine. So
yeah, I love that scene where I think it's the famous movie villain. It's Rodney Cox, I believe, is the actor's name, and he's like, "Yes, it's flawless. It'll work." And then, as you say, it destroys. I think,
and in the end, he's also like, "No, it worked. It worked."
That's Silicon Valley right there.
Right. So maybe to talk about, we don't have to take that as an example, the automated driving, but in general, this idea that sentient technology is around the corner is something that seems very dominant, ubiquitous. Yes. Many people think that way. Yes. And of course, as you said, also because they don't have the technical expertise, but also because they're being bombarded with this message constantly. Right. You seem, as everybody has noticed now, and me too, we seem pretty pessimistic about that. You quote an article by Melanie Mitchell, "Why Artificial Intelligence is Harder Than We Think." Why is it so hard?
One of the reasons it's hard, and this is also covered in that paper by Dr. Mitchell, is because we don't really understand what intelligence is. We have no solid definition for it. The term has been weaponized by racists to describe why one group is not intelligent, or one group is more intelligent than another. It's loosely thrown about to talk about why, we are allegedly more intelligent than cats and dogs, but we're not sure of that. And so, because we cannot even define it, how can we possibly build it? And there are also technical reasons, because we don't know exactly what the nature of cognition is as it navigates itself in the world. We have various ideas about it. People argue about it, and people argue about it quite passionately and assume that their ideas are correct. I'm a bit of a Hegelian on this, in which I'm looking for the dialectic between all these various factors. But I think that, to name another luminary, Chomsky, that there are limits to what we can understand, and we haven't even begun to actually crack that egg. So we don't know. Therefore, how can we build? And we're not even sure that the computational hardware that we have can support the kind of cognition that we dream of building. Our brains, of course, have no relation whatsoever to computation. People in the AI industry continue to try to sort of make these parallels, saying, well, a neural network, which is basically a software object, an algorithm methodology, is the same as as a human neuron. And then, actual cognitive scientists study the neuron and see that it is wildly complex. It's so complex that, that your mind boggles when you actually see a neuron. And we have only a hint of what's going on in ourselves. So that, at I think a practical level, is why constructing an artificial intelligence is so daunting. And also, I think that it's a foolish quest, because if we only said, what if we were to simply build useful tools, we might, over the course of generations, centuries, who knows, stumble upon the creation of machinery that could actually, think. But as an actual goal, as a kind of an industrial process, it's a quite it's a quite absurd undertaking, really. Although I know that by saying that, I sound like a heretic.
A Luddite. You just want to go back to the caves and eat raw meat. That's what you want. Well, but what about, okay, but because that question came in the comments, what do you say then to Timnit Gebru, this Google, the software developer that stepped out of Google, I think, exited out of Google because, oh my God, we have created a monster, the Lambda Google language model for dialogue applications.
Yeah, it's so this happens repeatedly. And well, not repeatedly. It's not as if every day someone does this, but it does happen, right? Where someone makes an announcement that, my God, what I've seen is so horrible. We don't know we don't know why they are. Well, let me start again. Whenever these claims are made, I always insist upon actually seeing the machinery at work. In other words, anyone can make a claim. I could say that this microphone is super sentient. But then if we were to tear it apart, you'd say, well, Dwayne, what are you talking about? And so the fact that the claim was made does not mean that the claim is true. The claim has to be interrogated, right? And the way to interrogate it, we talked about materialism, is to look at the actual thing that is supposed to be producing the state, right? So I think that such claims are not supportable by what we currently know. I'm willing to certainly investigate. I'm willing to support an investigation, but it would have to be something that would be, peer reviewed by a variety of people, and not just people working in this industry, and simply not accepted at face value because someone who has credentials is making a claim. I mean, people made credentials about phrenology in the early 20th century. That people's intelligence or criminality is based upon their skull size. Something that, by the way, is coming back with machine learning. And machine vision, people made all sorts of claims that are not true. So we always must be skeptical, and we always must interrogate the claims on a material basis by looking at, in this case, the code or in the machinery to actually determine what is the truth level of what's being stated.
And to be fair, maybe I got the name wrong or mixed that up, but I remember that there was this kind of developer jumping out saying, or maybe even being fired by Google.
He was suspended. He was suspended because his job was, and I don't recall the gentleman's name. He's an American, okay, but he has a French name. But he was suspended because he made a claim that that the platform is sentient and that it has rights as a consequence. This was his claim.
Right.
And so that was a bridge too far even for Google, I suppose. I mean,
although just the suspension going public, I would like to investigate what happened to Google stock the day after that.
Quite interesting, right? Right.
I mean, I'm not saying it's a conspiracy, but
it's quite interesting. Yes, like, oh, maybe he's telling the truth. Maybe they have some.
Yeah, exactly. They're trying to silence him.
Now, the thing about his statement is that the same types of statements were made decades earlier by people who used the ELIZA program at MIT.
Yes,
that Joseph Wiesenbaum created, right? And so, and that was a quite simple program. You can write that probably tonight with a few lines of code. And it ran on computational infrastructure that was orders of magnitude less than what Google brings to bear.
Right.
But but people had the exact same reaction to ELIZA. Tell me about your mother. These responses to queries. And so it tells us more about us than it tells us about the machinery. And that was the point of Joseph Wiesenbaum's book, Computer Power and Human Reason. I mean, he wrote an entire book about this that every person, I'm sure you've read it, every person in the computer science field should read. It is barely aged a day. And I think it was released in 1971. But you're reading it and you're like, well, did you write this yesterday? Because the exact same problems exist.
And back then they were also discussing, oh, maybe we don't need psychotherapists anymore. Maybe the computer can do it, and stuff like that.
Yeah, this is precisely right.
Yeah. Okay, that's good. Maybe I mean we talked a little bit about why it is, why it is most likely impossible, or at least not achievable in any short time frame. But maybe we can also talk a little bit about that the current way of going about to getting to artificial intelligence is increasing also the energy demand to such an exponential matter that we can, like, if it were true that we are on the right path to artificial intelligence, can we even support that? Like, and I'm just talking again materialistically from an energy perspective, right?
That isn't, see, that's an excellent point. Playing devil's advocate, that even if, let us say, the various projects that were underway, using large language models and image processing and so forth, even if those projects were indeed producing some kind of cognition, would it be worth it? Because the amount of computational power, and therefore the amount of power consumption required, is quite great. And how many more of these data centers would you have to build? How many more game processing units would you have to pour into the project in order to get these results? Particularly when we have, as we know, incredibly pressing issues, chief among them being climate change. And the cause of climate change is the pumping of CO2 into our atmosphere based upon the burning of fossil fuels. Now, these companies will say, well, we're using green energy, but we don't have firm data on that. And a lot of that is based upon having to have faith in what they're telling us. There is indeed, some use of solar, some use of wind, some use of hydro, perhaps even some data centers that are downstream from nuclear power, which is controversial for some. But primarily, it is the burning of fossil fuels that powers these data centers. And so if we were to do a calculation, and again, this is playing devil's advocate, and even assuming that they're telling the truth, if they had to continue to build out this infrastructure in order to achieve their goals, what we'd have the equivalent of Luxembourg covered with data centers in order to have a conversation. I don't think that in a democratic society that we would vote for that.
Right. That's also in one of your blog posts. The title is AI Ethics, a More Ruthless Consideration. You also raise this consideration as basically make an ethical argument that we should actually probably stop that shit. Like, at least not focus so much energy on that. If we were an economy that would deal towards, I don't know, use value of people. But
I mean, if we were to build a computational infrastructure that was dedicated to our needs, rather than these private efforts, which at this point, I'm not even sure we can call them a research program, because we know what they're doing. They're simply pouring more computational power into the exact same methodology to achieve more granular results. But I wouldn't call that a research program. I would call that an engineering effort. And there's a difference. I mean, engineering, of course, is essential, but if that effort was being poured into creating a computational infrastructure to help us solve our problems, then I think that perhaps we might agree. But it's not. It's being poured into the creation of privately owned platforms that will allow companies to charge for things. For example, what was it? The program, the platform that autocompletes code for people. GitHub Copilot, for example. That is now you have to pay for that now. For example, now that's based upon siphoning in code snippets from GitHub that thousands upon thousands and thousands of developers have contributed to projects. And now there's a paid service for it. And that service behind the scenes, of course, is inhabiting and consuming the power of multiple data centers. Is that worth it? Is that something that we should be doing as a civilization? And my argument is no. I'm obviously not anti-computation. I'm anti-computation for purposes that at this point do not benefit humanity.
So maybe we can examine this point a little bit further when we talk about the distinction that you make between AI hypes and AI
Mm.
propaganda. And I would
Mm.
like maybe ask right away if there is an AI propaganda, which sounds like something much more conscious and something much more
Mm.
active than just a hype, like a fashion or something like that. Why is there
Yeah.
a propaganda? What are the interests behind these kind of propagandistic elements?
So we can return to the self-driving truck story as an example of the difference between hype and propaganda. So let's say you and I own a company, and we're saying Nadim and Dwayne have a company that is producing self-driving trucks. We may hype that up. Our purpose for hyping it would be to attract customers. So that is a time-worn tactic that companies and organizations and people use all the time to big themselves up so that they appear to be, more interesting or more important than they are. And in the case of our hypothetical self-driving truck concern, as I said, we're trying to attract customers. On the other hand, if we say, and therefore you will not need truck drivers, and truck driving as a category will go away, well, then we're trying to have an impact upon political economy, not simply our own fortunes as business owners, but the entire structure of the society. And that is the function of propaganda. That's when you cross the bridge from hype, which is very close to advertising in its objectives, to propaganda, which has broader and deeper goals. And so that's what I would call the difference. And so, excuse me, when companies in Silicon Valley present the idea that they're building intelligence, they are doing so to not only attract investors, that's hype, but they're doing so to change the range of conversation so that people, for example, in parliaments and congresses around the world will have conversations about how do we deal with the threat from AI. When you have achieved that, you have changed the conversation, and that is the goal of propaganda.
Yeah, excellent. Great. I have a couple of other questions, but maybe just coming back to the point before, and I just did a quick Google. Timnit Gebru is actually somebody that also got fired from Google.
Oh, yes, you're talking about Dr. Gebru. Yes,
Dr. Gebru,
she
exactly.
along with Mitchell and a few others. I forget the name of the other researchers, sadly, and forgiveness for that to those
Emily
researchers.
Bender,
Thank
Dr.
you.
Jeff Dean. Yeah, a
Yes,
couple
Dr.
of
Bender, Dr.
researchers.
Dean. Yes,
Right.
they wrote a piece, Stochastic Parrots, which got Dr. Gebru fired from Google. And one of the major topics covered in that paper was the power consumption, in addition to the bias and so forth. And it asked the fundamental question, which was, is this actually worth it? What are we doing? And obviously, that would run afoul of Google. I think Dr. Gebru believed innocently that she was a researcher working in a research facility. And I think that what became quite clear as a result of that event was that it was revealed. I mean, for those of us who actually, I guess, monitor capitalism with a bit of a more arch eye, that, well, yes, of course, it was against Google's self-interest as a capitalist concern to ask questions about the
Sure.
hype, and the propaganda of their large language model efforts. And so Dr. Gebru and her colleagues, by asking fundamental questions, was, of course, shining a light in an area that they preferred not be shown.
Yeah, I mean that's really something that is out of the common mind, I would say. I mean,
Yeah.
there's actually a lot of information on this. I mean, here, for example, Tadeusz Cantwell writes, in Ireland, new data centers are projected to add multiple percentage points of extra to the national energy consumption demands. They already used 14% in total output in 2021.
14%.
That's humongous. I
Yes,
mean,
it's massive. I mean,
for
imagine
some,
14% of a nation's power output dedicated to data centers. And then he's saying that it's projected to even increase. So, this so even if these data centers are powered using renewables, we can ask another fundamental question: is Well, okay, that's fine, but that renewable power generation should be diverted to the needs directly of people, because who owns these data centers? Therefore, who benefits from, from these data centers? Now, someone might say, well, you're enjoying your cloud platform, your cloud career, and so forth, and uploading your photos and your videos, and all that's nice. But we're at a point where we have to ask tougher questions about how we're using resources. And data centers consuming such a significant portion of a nation's power output, that is astounding and not surprising, actually.
Yeah, exactly. And I think hopefully more research on this will come in. I mean, just imagine if you get some numbers on what AWS is or Amazon is using with its data centers.
It's very difficult because
it's also difficult. Yeah,
it's because none of these companies is upfront, of course.
Sure.
With
Right.
that data, but for those who want to research this, I do recommend that you contact power utilities, because they have that data. They know. And if you can find a friendly person within these organizations, that's the source of this data.
Okay. How is the time looking? Do you have a couple of more minutes for some more actions?
Yeah, I do.
Questions? Okay,
Yeah,
cool.
a few more minutes, sure.
Let's come back to this science fiction topic just for 1 second, because you have a cool article about that. You actually, I think in one of your recent posts, you actually start analyzing Star Trek episodes. And by the way, that's where you had me. That's so your argument there is that I think from the 70s, an episode from the original Star Trek series is more adequate and more correct when displaying or trying to deal with AI than we are today. How so?
In Star Trek, computation is presented as a tool. For example, the ship's computer, which is quite sophisticated by our standards, able to respond to voice and actually read and do a number of really quite useful things, is understood by all the characters in that world as not possessing intelligence at no point. There are a few exceptions. There are some episodes in which something odd happens, and of course, there's Mr. Data in the Next Generation series, who's considered a unique, organism or artificial organism built by Dr. Sung. But in the main, computation is viewed as an extremely sophisticated tool, and there is a clear line between what living beings do and what machines do. And this is illustrated in the classic series episode, The Ultimate Computer, in which the M5 computer is actually able to think. It is a new development, and it takes over the Enterprise. And by take over, I mean that this is done officially. It's not like a typical episode in which it takes over. And then, of course, everything goes to shit, and they have to disconnect it. But in the course of this episode, there's an interesting philosophical exchange between the creator of the computer, Dr. Daystrom, and Kirk and Spock, in which they talk about the clear line of demarcation between living minds and machines. And I think that vision that Star Trek sets out for computation is more realistic, in the sense that it's probably achievable for us to have text systems that could synthesize text. And if I were to say, hey, you know what, computer, tell me about all articles about nuclear fusion between 1980 and 2022 by the following person, that the computer would be able to create, or that the system, I should say, not just some random computer, would be able to create a summary that would be useful to me. That would be incredibly powerful. That alone would be an incredibly powerful tool, because it would accelerate scientific development. As you peruse, papers and so forth, that now we know that there are no doubt research papers languishing somewhere unread, unseen, that would be quite helpful to us, helpful to medicine and to physics, and so in all sorts of areas. And in Star Trek, this happens all the time, where they're going through a library, and then the ability to peruse this library of human knowledge enables them to move more rapidly to solve problems. It's actually a quite beautiful vision, and it's something that you'll notice that Silicon Valley never mentions. It's never something as simple as just that. It's always, no, no, GPT-3 is thinking. Well, I would just like GPT-3 to be able to read Wikipedia for me, peruse Wikipedia for me, and actually synthesize some answers in a logical fashion. It doesn't have to be able to think. It just has to be able to, in a sophisticated fashion, assemble, peruse a library and assemble data for me that would accelerate my ability to actually solve problems.
Yeah, I mean, even Commander Data in the Next Generation, he sits on the computer and browses
He has
the
to use the
library.
computer, yes.
He has to use the computer too.
the
Exactly.
very famous LCARS interface, because it's more
Right.
efficient for him to do that than it is for him to just siphon, go through his own thoughts.
Yeah, I think even I mean, it shows that the some of the writers of these shows were aware of the difference of, statistical library knowledge, let's say, that we can access somehow, and reasoning. I mean,
They were.
even in that Star Trek episode that you just mentioned, ultimately the machine goes south
Yes,
because of the machine's lack of reasoning. So this person
precisely.
says, "Hey, don't shoot down that starship. They're our friends," and then he goes
Yes,
like, "No, they're not our friends." Well,
yes.
this thing cannot reason with you, and I think that to conflate that constantly, it happens in
Even
Next
in
Generation.
2000, even in Kubrick's 2000, well, actually Stanley Clark,
Yes,
I'm sorry,
yes,
Arthur C.
exactly,
Clarke, and Kubrick's 2001, what was the problem with Hal? Hal
exactly,
was unable to parse something as simple as keep this a secret, keep the mission a secret until we reach our destination. Something as
right.
simple as that was beyond Hal's capability, um, which a human being, of course, could quite easily do. Like, Commander Bowman, we actually discovered this object orbiting Jupiter. Keep that a secret until you get to Jupiter. Yeah, okay, thanks. It would have been no
Yeah,
problem.
and it would rather even kill the astronauts, like
because
actually detach them from the starship, than
because
to give
it,
up on
it,
that
it
mission, right?
exactly, because it couldn't resolve the tension between lying to its colleagues and its imperative. And so these fictional visions of the 1960s and 70s are more sophisticated than what we have today. And I think the reason for this, Nadim, is because they were closer to that era, or they were in the era in which research in this area was still an academic and a genuine scientific pursuit. And so our vision now has been shaped by Silicon Valley, and that is a commercial vision. It is not a scientific vision. And so it was easier for the writers of Star Trek in 1968, or Kubrick and Arthur C. Clarke in 1969, to have these kinds of visions, because their references would have been scientists and not, say, an executive at Google, who simply would have made a series of absurd claims based upon their marketing requirements.
I mean, last movie reference, but there is this excellent movie, excellent in terms of at least regarding the astrophysics behind it, which is Interstellar.
Yes.
But even in that movie, I mean, even though they had this guy, I forgot his name, like one of the big popular astrophysicists, it was not Neil deGrasse Tyson, it was the other guy.
Thank God.
And this guy basically schooled them about, how a black hole would look like, what would be the dynamics, etc. So a lot of science went into that movie, but you still have these robots that are basically sentient things, right?
They have personality. Yeah.
They make jokes, and you can, he creates a relationship with them, and that
yeah,
still has
he's
to
even
be
at the end of the movie. He's even hanging out with him on the, I think, on
exactly.
the
He's having a beer with the robot
in Texas. I'm like, what?
Exactly. Yeah. Okay. Last question, and then I'll let you go. It's already over an hour. I don't want to stress your time too much. Maybe some positive spin, because we're critiquing a lot, and I think this is very important, and I think we should do that the majority of our time, because nobody else is. But then again, especially communists that do research on planned economies, for example, base a lot of their hope also on assumptions on the availability of modern computing technologies. So let's say, I don't know, machine learning, cloud computing, that can help a free society in the future to manage our production. There are even there are communist strands that want to take, for example, cybernetics, like the cyber communism people, and envision self-regulated computational systems with feedback loops that learn about, okay, there's increased demand of toilet paper over there, so let's produce more, or something like this, right? So do you see, apart from all the critics that we gave, do you see some liberatory potential in all these technologies? Is there something that can actually guide us towards the transcendence of capitalism in this technology?
I think not a transcendence of capitalism through computation. However, I think that computation can play a role absolutely in a public goods governance scenario, a socialist scenario. And all of us who are familiar with the history of Chile know about Cybersyn. We may not know about Stafford Beer, the cybernetician who actually designed it. And we may also not know about cybernetics, which is an even older field, which I'm returning to now because I find its insights to be actually quite powerful. And I'm going through this period now where I'm returning to things that were written in the 50s, 60s, and 70s, because I find that their way of thinking about these questions was more fundamental, more radical in many ways, because, as I said, the Silicon Valley era had not occurred. So a positive vision of computation would, I think, build upon the ruins of what Cybersyn was and other projects of that type. And yes, use feedback loops, because feedback loops, I think, are essential. But also an idea of computation distributed to the people, so that individuals or communities are able to use this powerful resource to help them. An example I give is that although climate change is global, its effects will be felt locally in a multitude of ways. And wouldn't it be a fantastic resource if communities around the globe had their own computational infrastructure available to them, abstracted as with cloud as a utility that they could use to do stat analysis, to track things, to control things they need to control, to use computation to actually aid them as a decision in a decision aiding factor, and also in a command and control factor, but for public goods. And so once liberated, I think, from capitalist concerns or capitalist imperatives, computation's future can truly begin. My position is that computation is frozen, that we got stuck somewhere around 1990 or so, because there are people who are younger than me who will say to me, well, you must be very impressed by all the things that have happened. And I'm like, I'm not impressed at all, because there's literally nothing happening that is not simply a matter of more hardware. There's
a rehash, basically, right?
Yeah, it's a rehash of things that are happening. And it's not because there's not more that could happen. It's because capitalism via corporations is preventing it from happening. And so, I believe it is actually, I believe it was Marx who actually observed that the bourgeoisie at one point was revolutionary, but then, of course, when it ceased to be revolutionary, it was unable to break itself out of its own loop, essentially. And that's what we're seeing. And so, however this happens, and I cannot predict the future, obviously, but I'll do my part to advocate for it. However this happens, once computation is liberated from capitalist control, then the future can resume. We can resume the work of actually building computation.
Yeah, it's. I think what you're referring to, at least what I was referring to, is like this, old Marxist idea of the dialectics of the productive forces, right? So the productive forces basically make possible the transcendence towards a new system, towards a new way to organize society. But the productive relations, which basically is the way that we organize these productive forces, keep us from doing that, and stifles the potential, right?
And it stifles the potential, precisely.
Right. And well, now I forgot my last point, but then I can say that's a very, very good point to end on, because I think that's what we should think about. So it's ultimately not about, getting rid of computation, but really asking what are we using it for? To
Yes.
what end? What is the purpose of it? And the way that it goes now, it's probably not the one that we would want to go if we were in a liberated society. Okay.
Mm-hmm.
Dwayne, this was seriously a lot of fun. I really enjoyed speaking to someone that knows a little bit on this topic. So I would love if you rejoined us maybe in a couple of months from now.
Yeah, that would be fine. That'd be fine.
Okay, cool. And then thanks to everybody that was in the chat, everybody that was live with us. And thanks again, Dwayne. Have a nice evening. And
thank you. See you too.
See you soon, everybody.
Leute, wir brauchen eure Hilfe. Wenn euch dieses Video gefallen hat, klickt auf Like, abonniert den Kanal und vergesst nicht, das Glöckchen zu drücken, damit ihr benachrichtigt werdet, wenn wir neuen Content droppen.
Außerdem solltet ihr uns überall folgen, wo wir verfügbar sind. Das ist Facebook, Instagram, Twitter und Twitch. Und wenn wir irgendwelche Ankündigungen machen oder Posts, dann shared, was das Zeug hält. Gebt uns all eure Liebe.
Wir haben mittlerweile ziemlich signifikante Kosten. Wenn ihr es euch irgendwie leisten könnt, unterstützt uns doch auf Patreon. Dann kommt ihr auch in den Genuss verschiedener Vorteile, wie zum Beispiel Zugang zu unserer Discord-Community oder Zugang zu den ultrageheimen Patreon-Episoden, die wir dort posten. Außerdem könnt ihr uns natürlich auch über PayPal Spenden zukommen lassen.
Außerdem haben wir mittlerweile einen eigenen Online-Shop. Das heißt, wenn ihr euch immer noch fragt, was ihr euren Lieben zu Weihnachten, Ostern oder sonst wie schenken könnt, geht dorthin und kauft duftes Merch.
Alle Links dazu hier in der Beschreibung oder auch auf unserer Webseite 99zu1.de.
Vielen Dank fürs Dabeisein, danke für die Unterstützung und wir sehen uns in diesem Theater.